Welcome back. Let's continue to look at our new identity, which is going to be the sum or the difference of angles in a cosine. So we can have the cosine of two angles being added together, and then we get a somewhat messy but doable formula for that, just in terms of the angles of the individual cosines and sines. Or we can take the cosine of a difference of angles, remembering that the sum becomes a difference and the difference becomes a sum. So it just flip-flops. So let's take a look at another example here. We've got the cosine of a 62 degree angle times the cosine of a 17 degree angle plus the sine of a 62 degree angle times the sine of a 17 degree angle. Well, this just looks like a big mess because I certainly couldn't compute the cosine of a 62 degree angle in my head. I would have to use a calculator. The same way with the cosine of a 17 degree angle or the sine of those angles either. However, one thing that we'll notice, and maybe this is pretty clear, we've got cosine plus sine and sine. And we've got the same angles. We've got the cosine of 62, sine of 62, cosine of 17, sine of 17. This is exactly one of our identities. And because we are adding, this is going to be the cosine of the difference of angles. So this is going to be the cosine of a 62 degree angle minus the 17 degree angle. So again, this is just our identity, just sort of used in reverse. We're told that we're multiplying the cosines of these angles plus the sines of these angles. So we just have to reverse engineer what the original difference was. And if we take this difference, I think we end up getting the cosine of a 45 degree angle. And this is one of our special angles. The cosine of a 45 degree angle is root 2 over 2. So, and it's good to remember that the special angles that we need to remember are going to be 30 degrees, 45 degrees, and 60 degrees, as well as any multiples of 90. So these are kind of some of our special angles, but we also have 0 degrees, 90 degrees, 180 degrees, 270 degrees, and so on. So all multiples of 90. These are the sorts of angles that you should just know how to take sines and cosines and tangents of right away. So let's do an example of something like that, and let's find the cosine of a negative 15 degree angle without a calculator. And there's a couple of different ways to do this, but what I'm going to do is I'm going to notice that, okay, they're asking us to do this without a calculator. So we had better use angles that we can actually know how to take sines and cosines of. And what we'll notice is that a lot of these right here have differences of 15 degrees. So I could make negative 15 by, say, taking 30 minus 45. So this is one way of writing negative 15. There are other ways. I could also write it as 45 minus 60, but I think I'm just going to use, I think I'll just use these ones right here. So if I'm being asked to do this without a calculator, let's rewrite this guy in terms of better angles that I know how to work with. So the cosine of a negative 15 degree angle, well, this is just the same thing as a cosine of a 30 degree angle minus a 45 degree angle. So far, I haven't done anything but rewrite negative 15 as 30 minus 45. And then what I can do is I can then use my identity. So 30 minus 45, this is going to be the cosine of the first angle times the cosine of the second angle. And if I'm taking a difference of angles in the cosine, it becomes a sum of angles outside. So this is going to be the sine of a 30-degree angle times the cosine of a 30-degree, cosine of a 45-degree angle. I made a mistake already. This should be the sine. Cool. And then, so right away, 45-degree angles are my favorite. These are the ones that I remember the easiest. So cosine is the sine of 45-degree angles. Those are always just root 2 over 2. So it's going to be times root 2 over 2. So all I have to do now is remember what the cosine 30-degree angle and the sine of a 30-degree angle. And again, sines of 30-degree angles are the ones that I remember first. So this is going to be 1/2. And the cosine of a 30-degree angle is going to be root 3 over 2. Again, cosines and sines of 30-degree angles, 45-degree angles, 60-degree angles, all of these should be ones that you should be able to rattle off the top of your head. So it's worth memorizing these. Okay, and then now all we have to do is multiply this up and see what we get. So root 3 over 2 times root 2 over 2. So we'll have root 3 times root 2 over 4 plus, and then over here we have 1 times root 2 over 4. Well, we have the same common denominator, so that's just going to be 4. Root 3 times root 2 is root 6, and 1 times root 2 is root 2. And this is as simple as we can make it. Cool. So we have our cosine of a negative 15-degree angle. So this is, again, something that this isn't one of our special angles, but it does have a nice formula at the end because we can write it in terms of our special angles. So this is a little bit uglier than just say root 2 over 2 or even 1/2. But in the grand scheme of things, this isn't some horrific decimal that we can only find by using a calculator. We can write it in terms of square roots and fractions. I think there's 2 more. I'll do the last question in another video because it'll be a little bit longer. But this one, I want to write sine of x minus pi halves without a difference of angles in a trig function. And there's going to be a lot of different ways to do this. So I'm just going to go through a couple of different ways and show you that we can use a lot of the information that we've seen to be able to handle this guy. So let's do this in one way. First of all, I have a sine of a difference of angles. We have only seen cosines of differences of angles. So none of our formulas work for the sine function. This will be we'll look at differences in the next video, or sorry, in the next section that we look at. But we can turn sine into cosines using our co-functions. So let's write this down. If I want to rewrite a sine as a cosine, what I plug into them have to be complements. So let's work out what the complement of this guy is. So if I write sine of x minus pi halves, and I want to know what do I plug in to cosine to make that work, well, I know that this guy, this angle, and this angle have to be complementary angles. So let's work that out. X minus pi halves plus y should be equal to pi halves. Again, 90 degrees in radians is going to be pi halves. So let's work out what y should be. Well, y, if I subtract, sorry, I need to add pi halves to both sides. And then I'll need to subtract x. and I would get that y is going to be pi minus x. Cool. So what I can do is then write sine of x minus pi halves is the same thing as cosine of pi minus x. So far so good. I've rewritten this in terms of a cosine, and now what I can do is I can take that and use my formula. So again, cosine, when we have a sum or a difference inside of a cosine, we know that we can write this as cosine pi cosine x, sine pi sine x, and since I was subtracting it before, I will now have to add it. And now it's just a matter of going through and actually remembering what some of these are. The sine of a pi degree angle. This is one of our special functions. Again, pi is the same thing as 180 degrees, and sine of 180 degrees is 0. Well, that's going to simplify quite a bit. Cosine of 180 degrees is going to be, let's see here, so this is another one that we can do. Cosine of 180 degrees, well, that's -1. So anything times 0 is 0. And if I add 0, I don't change anything. And -1 times cosine, well, that's just negative cosine. So that's pretty simple. As in, this doesn't have any differences of angles in here. We've just written it as minus cosine. Let me do this in one other way, which is going to be a little bit quicker than this because we don't have to find the complement of an angle. And that's to do the following. Sine of x minus pi halves. I'm going to use a little trick, and then I'll show you why this trick really works. Sine of x minus pi halves. X minus pi halves. This is the same thing as the following. Sine of negative pi halves minus x. All I did is I pulled out a negative sign. If you pull out a negative sign from the x, we're going to get negative x. So negative x is that positive x, so that matches. And then I have negative pi halves and negative pi halves. So nothing has changed here. I've just written it with a negative sign pulled out. And when we are taking the sine of a negative angle, I can pull out the negative sign. So this is going to be negative sine of pi halves minus x. And here, what is the complement? So here, I've got negative sine of pi halves minus x, and this is a very easy angle to take the complement of. Because if I want the complement of this angle, let's say the complement is y, what should that be? Well, pi halves minus x plus y should be equal to pi halves. Again, the sum of my original angle plus y should be 90 degrees, or pi halves. Well, we see that y and x just have to be the same. If I subtract pi halves from both sides, I get minus x plus y is equal to 0, or y is just equal to x. So, y, the complement of this angle, is just x. So, using our cofunction identity, sine of this angle is cosine of x. But I can't forget the negative sign. So I get the same thing in both ways. Both ways absolutely work. Up here, I just used my cofunction identity right away. So I wrote this function as cosine of pi minus x. Down here, I made it a negative angle, and then took my cofunction identity. And that made the cofunction identity a little bit easier, but both absolutely work.